I am Dr. Vishnu Kumar. Today I discuss characterize immune system. First, white blood cells, the immune response, immunity, and immune system disorder. Our immune system is essential for our survival. Without an immune system, our bodies would be open to attack from bacteria, virus, parasite, and more. It is our immune system that keeps us healthy as we drift through a sea of pathogens. White blood cells are also called leukocytes. They circulate in the body in blood vessels and the lymphatic vessels that parallel the vein and arteries. White blood cells are on constant patrol and looking for pathogens. When they find a target, they begin to multiply and send signals out to other cell types to do the same. Our white blood cells are stored different places in the body, which are referred to as lymphoid organ. These include the following: thymus, a gland between the lungs and just below the neck; spleen, an organ that filters the blood. It sits in the upper left of the abdomen. Bone marrow, found in the center of the bones. It also produces red blood cells. Lymph node, the gland positioned throughout the body, linked by lymphatic vessels. There are two main types of leukocytes: phagocytes. First, these cells surround and absorb pathogens and break them down, effectively eating them. There are several types, including neutrophils. These are the most common types of phagocytes and tend to attack bacteria. Monocytes. These are the largest type and have several roles. Macrophages. These patrol for pathogens and also remove dead and dying cells. Mast cells. They have many jobs, including helping to heal wounds and defend against pathogens. Lymphocytes. Lymphocytes help the body to remember previous events and recognize them if they come back to attack again. Lymphocytes begin their life in bone marrow. Some stay in the marrow and develop into B cells. Others head to the thymus and become T lymphocytes, T cell. These two cells types have different roles. First, B lymphocytes. They produce antibodies and help alert the T lymphocytes. Second, T lymphocytes. They destroy compromised cells in the body and help alert other leukocytes. How an immune response works? The immune system needs to be able to tell self from non-self. It does this by detecting proteins that are found on the surface of all cells. It learns to ignore its own or cell protein at an early stage. An antigen is any substance that can spark an immune response. In many cases, an antigen is a bacterium, fungus, virus, toxin, or foreign body. But it can also be one or our own cells, that is, fecate or dead. Initially, a range of cell types work together to recognize the antigen as an invader. The role of B lymphocytes. Once B lymphocytes spot the antigen, they begin to secrete antibodies. Antigen is short for antibody generator. Antibodies are special protein that lock onto a specific antigen. Each B cell make one specific antibody. For instance, one might make an antibody against the bacteria that cause pneumonia, and another might recognize the common cold virus. Antibodies are part of a large family of chemicals called immunoglobulin, which play many roles in the immune response. Immunoglobulin mark microbes so the other cells can recognize and deal with them. Immunoglobulin M is expert at killing bacteria. Immunoglobulin A congregate in fluid such as tears and saliva, where it protect gateway into the body. Immunoglobulin E protect against parasites and it also to blame for allergy. Immunoglobulin D stay bound to B lymphocyte, helping them to start the immune response. Antibodies lock into the antigen, but they do not kill it, only mark it for death. The killing is the job of other cells such as phagocytes. The role of T lymphocytes. There are distinct types of T lymphocytes. Helper T cells. They coordinate the immune response. Some communicate with other cells, and some stimulate B cells to produce more antibodies. Others attract more T cell or T eating phagocytes. Killer T cells, cytotoxic T lymphocytes. As the name suggests, these T cells attack other cells. They are particularly useful for fighting virus. They work by recognizing a small part of the virus on the outside of infected cells and destroy the infected cells. Immunity. Everyone's immune system is different but has a general rule. It becomes stronger during adulthood, as by this time we have been exposed to more pathogens and developed more immunity. That is why teens and adults tend to get sick less often than children. Once an antibody has been produced, a copy remains in the body, so that if the same antigen appear again, it can be dealt with more quickly. That is why with some disease such as chickenpox, you only get it once as the body has a chickenpox. Antibody stored ready and waiting to destroy it next time it arrives. This is called immunity. There are three types of immunity in human called innate, adaptive, and passive. Innate immunity. We are also born with some level of immunity to invader human immune system similarly to those of many animals. We attack for invader from day one. The innate immunity include the external barriers of our body. The first line of defense against pathogens such as the skin and mucous membrane of the throat and gut. This response is more general and non-specific. If the pathogens manage to block the innate immune system. Adaptive or acquired immunity kicks in. Adaptive या acquired immunity. The protect for pathogens developed as we go through life, as we are exposed to disease or get vaccinated. We build up a library of antibodies to different pathogens. This is sometimes referred to as immunological memory because our immune system remembers previous enemies. Passive immunity. The type of immunity is borrowed from another source, but it doesn't last indefinitely. For instance, a baby receives antibodies from the mother through the placenta before birth and in breast milk following birth. The passive immunity protects the baby from some infections during the early year of their life. Immunizations introduce antigens or weakened pathogens to a person in such a way that the individual doesn't become sick but still produce antibodies because the body saves copies of the antibodies. It is protected if the throat should reappear later in life. Immune system disorder. Because the immune system is so complex, there are many potential ways in which it can go wrong. Types of immune disorder fall into three categories. Immunodeficiencies. These arise when one or more part of the immune system do not function. Immunodeficiencies can be caused in a number of ways, including age and alcoholism in developing countries. Malnutrition is a common cause. AIDS is an example of an acquired immunodeficiency. In some cases, immunodeficiencies can be inherited. For instance, in chronic granulomatous disease, where phagocytes do not function properly. Autoimmunity. In autoimmune conditions, the immune system mistakenly target healthy cells rather than foreign pathogens or faulty cells. In this scenario, they cannot distinguish cell from non-cell. Hypersensitivity. With hypersensitivity, the immune system overreact in a way that damage healthy tissue. An example is anaphylactic shock, where the body responds to an allergen so strongly that it can be life-threatening. In a nutshell, the immune system is incredibly complicated and utterly vital for our survival. Different system and cell type work in perfect synchrony most of the time throughout the body to fight off pathogen and clear up these cells. Thank you.